Hey everybody, so in this video we're going to cover some material from section 7.2 and some material from section 7.3, but we're focused on the graphs of exponential and logarithmic functions. Okay, so we're going to start with exponential functions. Okay, and we're going to start with the base graph, which is b to the x. Okay. Okay, so we're going to look at the key points first. Okay, so our key points for this base graph are -1, 1 over b, 0, 1, and 1b. Okay, so those are our three key points. We also have a key feature to this graph. Okay, which is a horizontal line the graph doesn't cross at y equals 0. Okay, now we looked at other graphs that have these types of features. The 1 over x and 1 over x squared graph both have these types of horizontal lines that the graph doesn't go across, but it just shows you the shape of the graph. Okay, so in your homework, you'll see that these lines are called horizontal asymptotes. Okay. So when you see that in the homework asking about the horizontal asymptote, this is what they're asking about, that horizontal line that shows where the graph goes, but the graph does not actually cross that line. Okay, so let's go ahead and look at the base graph. Okay. Okay, so there's actually two base graphs. There's one for b greater than 1, and there's another one for b less than 1. Okay, the key points are all the same, they just look different. Okay, so for b greater than 1, right, 1 over b, the first key point, is going to be a fraction. Okay, so that's going to be somewhere over here. Okay, and then at 1, the y value is going to be b, which would be greater than 1, right? So that's going to be somewhere up here. Okay, then we have that horizontal asymptote along the x-axis here. Okay, and the shape of the graph looks like this. Okay, now if b is less than 1, then 1 over b is going to be a number bigger than 1. Okay, so it's going to be something like this. Okay, the point 0, 1, and then 1 comma b, because b is something that's less than 1, right, is going to be something that's less than 1. Okay, still have this horizontal asymptote that goes along the graph here. Okay, and we have this shape. Okay, so you can see that the shapes are just reversed here, right? This one goes up, this one comes down. They should be the same shape, just reversed from each other, right? Or reflected, as we've been saying about our graphs. Okay. All right, so let's go ahead and look at some examples. Okay. Okay, so we're going to graph these types of graphs using base graphs and transformations. So part A is just going to be graph the base graph y equals 2 to the x. Okay, so this is the base graph that we're going to use for this example. We'll just do 2 to the x. Okay, so our key points are going to be -1, 1 over the base. Okay, 0, 1, and then 1 comma base. Okay, so since the base here is 2, this is 1 over the base, 0, 1, and then 1 comma base. Okay, so let's look at our base graph. Okay, so we're going to have that horizontal asymptote along the x-axis here that the graph doesn't cross. And then we're going to graph our 3 key points, -1, 1/2, 0, 1, and 1, 2. Okay, and then we're going to draw in this basic shape where it's curved up like this. Okay. All right, so that would be the graph of 2 to the x. So let's look at some transformations of that base graph. So the transformations are going to be the exact same transformations that we saw with other base graphs. Okay, so let's look at some base graph transformations here. Okay, so of course this is going to be the base graph 2 to the x power, okay, and this minus sign is going to reflect it, okay, up and down or across the x-axis. Okay, so let's go ahead and look at our graph. Okay, so just like before, we are going to have this horizontal asymptote along the x-axis, okay? It is reflected, but it doesn't look any different when it's reflected, okay? So we're going to take this point and reflect it down here. We take this point and reflect it down here, and this point reflects down here, okay? And then we're going to draw the graph like this. Okay, you can see that the graph has the same shape and that it's just upside down, right? We know that's what reflection does. It's at least this y-type reflection where it reflects it across the x-axis. Okay, let's look at another transformation. Okay, so we can see that we're going to use the same base graph 2 to the x, okay, and that this -3 is going to move the graph down 3. Okay, so let's go ahead and draw our graph. Okay, so looking at our base graph, which is right here, right, we can see that this horizontal asymptote is at the x-axis. We're going to move that down 3. So we're going to move it down from here 1, 2, 3, and then we're going to go ahead and draw that dotted line in. Okay, and then we're going to move each of our key points down. So we're going to move this key point down 1, 2, 3. This key point moves down 1, 2, 3. And this key point moves down 1, 2, 3. Okay, and then we draw in the shape of our base graph. Okay. All right, let's look at one more transformation. Okay, now when we times something by 3 like this, we know that it is going to stretch it vertically times 3. Okay, so the y coordinate of all the key points is going to be multiplied by 3. So remember, our original key points were 1, 1/2, 0, 1, and 1, 2. Okay, so we're going to multiply all of our y coordinates by 3. So x coordinate is the same, y coordinate gets multiplied by 3. So 1/2 times 3 is 3/2. Okay, same here. X coordinate is the same. Y gets multiplied by 3. 1 times 3 is 3. Okay, same here. X coordinate is the same. The y coordinate gets multiplied by 3. So 2 times 3 is 6. Okay, so let's look at what our graph would look like. Okay. Okay, so the horizontal asymptote is at 0. 0 times 3 is still 0. So that's still going to be here. Okay, and then we're going to draw in all of our new key points. So we had -1 3/2, right, which is 1.5. So we'll go to -1, 1.5. Okay, 0, 3. Okay, and 1, 6. 1, 2, 3, 4, 5, 6. Okay, and then we're still going to draw in that basic shape. Okay, and you'll note that the graph is still going down towards the asymptote, even though it's stretched out. Okay. All right. So that's our first example with the base graph 2 to the x and 3 different transformations. Okay. So for exponential functions, let's look at a second base graph. Okay, so the first thing we're going to do is graph our base graph. So part A is going to be graph the base graph. Okay, and we're going to go with a base this time that's less than 1. Okay, so we're going to look at the graph 1/3 to the x. Okay, so our key points are going to be -1, comma 1 over 1/3. Okay, now we might want to simplify this a little bit. Okay, so 1 over 1/3, right, is 1 divided by 1/3, or 1 times 3. Okay, then we have 0, 1. Okay, that key point is already simplified. Okay, and then we have 1, 1/3. So that one's already simplified also. Okay, so let's go ahead and look at that graph. Okay, so I have that key feature of the horizontal asymptote along the x-axis here. Okay, then I have -1, 3, 1, 2, 3, 0, 1, and 1, 1/3. Okay, and I'm going to draw in that basic shape of the curved shape. Okay, but this is exponential decay. Okay, remember from the very first section that we said if the base is greater than 1, we have exponential growth. If the base is less than 1, we have exponential decay. Okay, so you can see that the graph is decreasing over time. Okay, let's look at some transformations. Okay, now this is inside of the main function, right? The 1/3 to the x function. So this means it's going to affect x. Okay, so minus 2 means that it's going to move the graph right 2. Okay, so let's look at our graph. Okay, so we are going to shift our horizontal asymptote, but it doesn't actually look any different. Okay, and then we're going to move all of our key points. So you can see our original key points here. We're going to move them all right 2. So we'll move this one 1, 2, moving this one 1, 2, and we're moving this one 1, 2. Okay, and then we're going to graph in, oops, it's not a very good graph, our graph here. Okay, so make sure that you don't go across this asymptote. Your graph doesn't cross that line. Okay, but it does cross the y-axis. It looks kind of funny because the graph is going pretty straight up, but it will eventually cross the axis here. Okay. All right, let's look at one more transformation of this graph. Okay, so again, when you have multiplication out in front like this, you know that this is going to be a stretch. So this is going to stretch vertically, okay, times 2. So we're going to take all of our key points from the original graph, which are these ones, and we're going to multiply all the y coordinates by 2. So we originally had -1, 3, 0, 1, and 1, 1/3. So we're going to multiply all of the y coordinates by 2 here. Okay, so -1 and then 3 times 2 is 6. X coordinate is the same, 0. 1 times 2 is 2. Okay, and then here x coordinate is the same. Y coordinate times 2, 1/3 times 2 is 2/3. Okay, so there's our new key points. All right. And remember that line is at y equals 0. 0 times 2 is still 0. Okay, so that won't look any different. All right, let's look at the graph here. Okay, so our horizontal asymptote is still at 0. Okay, and then we're going to graph all of our key points. -1, 6, 0, 2, and 1, 2/3. Okay. All right. So that's what we're going to do with our exponential graphs, right? Graph the base graph itself, okay, and then use the transformations to change the graph. So let's look at our logarithmic graphs, okay? So we're going to look at okay, we're going to look at the base graph, which is y equals log base b of x. Okay, so it has 3 key points. Okay, so it's going to be 1 over b -1, 1, 0, okay, and b 1. Okay, if you notice, these are exactly the key points from the exponential functions, just reversed, right? And there's a reason for that. It's not a coincidence. The log is defined as the inverse, and we know that inverses switch x and y. So this is doing exactly that, same key points, just switch x and y. Okay, and there's also a key feature. Okay, there's a vertical line that the graph doesn't cross. Okay, at x equals 0, okay? And this is called a vertical asymptote. Same word, asymptote, describing a line that the graph goes towards but doesn't cross, okay? But this time it is vertical, right, up and down instead of left and right. So you will see the name vertical asymptote a lot in the homework assignment when it's asking you about the graph. Okay, so let's look at the basic shape of the graph. Okay, so we've got this vertical line along the y-axis the graph doesn't go across. Okay, so we've got 1 over b negative 1, then we've got 0, 1, and then we've got b1, like this. Okay, oops. And this is the basic shape of our log graph. Okay, it should look to you like the exponential graph reflected across the line y equals x. And of course it is that graph because those are inverse functions. Okay, so same basic shape, just reflected. All right, so let's go ahead and look at some examples. Okay, so again, we're going to graph using base graphs and transformations. So part A is going to be to graph the base graph. Okay, and we're going to use log base 2. Okay, so our key points are going to be 1 over 2, right? 1 over the base negative 1. Okay, and then 1, 0. And then base, which is 2, 1. Okay, so let's look at our base graph here. Okay, so we're going to have that vertical asymptote, the line that the graph doesn't cross, here along the axis. Okay, then we have 1/2 negative 1, 1, 0, and 2, 1. Okay, so the basic shape of our graph is going to look like this. Okay. All right, let's look at some transformations of this graph. Okay, so because this is inside of the graph, we know it's going to affect the x coordinates. We know that negative signs always reflect, so we're going to reflect the x coordinates, okay, which is across the y-axis. Okay, so let's look at what that graph would look like. Okay, we're still going to have our vertical asymptote here at 0. Okay, and then we're going to reflect all of our points across. So the point that was here is going to get reflected across here. The point that was here is going to reflect across here. Okay, and the point that was here is going to get reflected across like this. So we can see that the graph is backwards of what it previously looked like. Okay. All right, let's look at another transformation. Okay, so we know that the 2 in front is going to stretch the graph times 2. Okay, so let's look at what the key points are. So our original key points were 1/2, -1, 1, 0, and 2, 1. Okay, so we know that when we're stretching it vertically, the x-coordinate is going to stay the same, so we'll still have 1/2, but the y-coordinate is going to be multiplied by 2, so we'll get -2. Okay, same here, x-coordinate is the same, y-coordinate is multiplied by 2, 0 times 2 is 0. Okay, and same here, x-coordinate is the same, y-coordinate is multiplied by 2. Okay, so let's go ahead and look at our graph. Okay, so because the x-coordinate is the same, that means that our vertical asymptote is still going to be the same. Okay, and then we're going to mark our key points. So 1/2, -2, 1, 0, and 2, 2. Okay, so let's draw that in. Okay, so you can see that compared to the original graph, it's a lot taller, right? And it's not flattened out as much, but it does have that same shape. Okay, a couple more reflections for this graph. Oh, I labeled that part C even though I already had part B, so this is really part C here. So then we're on part D, which is our last transformation. Okay, now we can see it's inside of our function, so that means it's going to affect x. So the +3 is going to move it left 3. Okay, so let's look at our graph. Okay, so our vertical asymptote is going to move left 3. So it starts here, we're moving it left 1, 2, 3. Let's dot it in. Okay, and then we're going to move all of our key points left 3. So this one is going to move left 1, 2, 3. This key point moves left 1, 2, 3. Okay, and this key point moves left 1, 2, 3. Okay, and then we'll draw in our basic shape like this. All right. So that's really all there is to graphing logs and exponential functions. You do kind of have to graph the base graph first because it's not a matter of memorizing the base graph, but a matter of figuring out the base graph for that base, right? Because each base would be a different base graph. So you have to draw the base graph and then use the transformations. I hope that makes sense, and I will see you guys soon.